There we go. There, it's recording now. All right, let's get started. I'm going to share my screen. And that should be that screen. Yep, share it. And we are going to go to the PowerPoint that is here. Right here, this one. Okay, so balancing equations. That's to wake you up. All right, so when the main thing about balancing things is knowing what things mean, okay? When you're balancing an equation, if you have a Cl2, basically this is what you have. So you have a molecule or molecule of 2 atoms of chlorine bonded, right? If you have 2 Cls, that the 2 in front of it, that means you have 2 separate atoms of Cl. And if you have 2 Cl2, you have 2 of the first ones. So a total of 4 atoms. You see that? So that's the main thing, is that you have to know what we're looking at. Because if you don't understand, then how can you balance? All right, and then you may also have things with parentheses like CaO2, and that just means that you have 2 OHs, right? Right here, 2 OH2s, 2 of them, but only 1 Ca. You see that? So when you're looking at that, let's see if you understood what we're talking about. Let's see, tell me how many atoms of each are in these. And I mean like each element. How many atoms of each element are in A?
Would it be 3?
No, of each element. There's
One.
3 atoms,
One of
but of each element, there's 1 of each, right? 1 of each. Yes, 1 sodium, 1 oxygen, 1 hydrogen. What about in B?
There's 1 of Ca and 2 of oxygen and hydrogen.
That is correct. And what about in C?
3 Cas and then 2 hydrogens and 2 oxygens.
Okay, that 3 in front of the Ca is multiplying everything.
Okay, so 6 oxygens, 6 hydrogens.
Correct. See, that's what you need to know, because how can you balance if you don't know what you're doing, right? And that's the main thing, that 3 in front, which is known as a coefficient, actually multiplies anything that it is in front of it that is not separated by a plus. Okay. So let's look at that. All right. So when we look at reaction types, we will be using this thing right here. This is known as an activity series of metals. And yes, I know that hydrogen is not a metal, but the rest are. So that's why it's called that. In order to look at it, you would, you are able to predict products. That's the main thing with knowing which type of reaction you could have or have. Like in this case, when I look at it, I see iron and copper 2 sulfate, and I know what's going to make, because that iron, if you look over here on the right, iron is right there where I'm pointing. I don't know if you can see that. I think this is where you got a spotlight. Hold on. Because these are a little different from mine. So annotate. Yeah, there we go. I need a spotlight. Okay, right here. Still not spotlighting. Come on. There. Can you see it right there? Can you see my spotlight? Nope, that's a pen. Man, what are you doing? This is not letting me spotlight. That is so annoying. Okay, there we go. See it? Okay, so iron is right there and copper is way down here. The rule with this table is that whatever's on top can replace anything on the bottom. Okay, so iron being on top can replace copper. So that means it's going to boot copper out of here, right? And take its place. So the main thing with a single displacement reaction like this one is to look at the metals. And if the metal that is by itself is stronger than the metal that is bonded, then that reaction will happen, okay? All right, the next reaction, oops, now I gotta get rid of this thing, get back my mouse. Okay, the next reaction that will happen is this one. Will this reaction happen or not? Look at nickel, look at sodium. Where is sodium? Where is nickel?
Is nickel on top?
No, nickel is on the bottom. You
Yeah,
see
so
that?
sodium's on top.
Yeah, sodium's way up here. Sodium's the second one, and nickel's a green one. So if you look at green, the green area, that'll show you. So that means that reaction will not take place, right? Because nickel is not on top. All right, what about aluminum and copper?
Yeah, aluminum is on top.
Okay. What about lithium and zinc?
Lithium is on top.
Yes, very good. Lithium and hydrogen.
Lithium is on top still.
Okay, so all of these reactions will happen except one so far. And then this next reaction is neither, it's not a single displacement, but it's known as a combination reaction. And you will see the difference in here in a minute. Okay, so the first one, you have to keep in mind that iron can be a +2 or a +3. In this case, we have a +3, and we have to put it accordingly, right? Make that compound accordingly. That's the main thing. But you notice how iron got into the compound and now copper is by itself. And that's the main thing in a single displacement. You're going to see a metal that's floating around on both sides. And it's going to be the different metal. Okay. So this one, we said it wouldn't happen. The next one, you expect it to be aluminum and copper switching places. So in this case, copper is the +2 because you can see that with the chlorine. And then aluminum, we know it's in the third group, so it's going to be AlCl3, right? Plus copper. And then lithium and zinc. Lithium is a 1 and zinc is a 2. So when you combine them, it's going to be zinc is booted out and lithium gets to be 2 of them, because it has to replace that zinc that was a 2+. These two are going to be 1 to 1, right? The main thing is knowing what water does. Water breaks up into hydrogen and hydroxide. So lithium is going to become lithium hydroxide and hydrogen gas. You see that? And aluminum and oxygen are going to bond together, okay? This is known as a synthesis reaction. And they're going to bond together based on what they do, which is they know that one's a 3, the other one's a -2, so they're going to be Al2O3. Now, none of these are balanced, right? In order to balance, we're going to have to look at the most complicated one first, which is this guy right here, right? Yes?
Yeah.
And when you look at it, you're going to compare against the others. Okay, so you're looking at 2 irons here. There's only 1 here. And then, but that's not the one that we're gonna more interested in. You always want to balance the bigger molecules first, because the ones that are by themselves may change because of the changes that you're doing to the big molecules. So you got to look at those 2 first. You notice there's 3 SO4s here, but there's only 1 here. Remember, we said we cannot do anything but add, right?
Mm-hmm.
A coefficient. That's all we can do. We cannot play God and put numbers that aren't there. Okay, so we cannot do that. All right, so now that you can see there's a 3 in front of the copper, well, there's only 1 copper, so we need a 3 in front of this copper, right? In iron, there's a 2 in front of it, so we need a 2 in front of there. This one we don't balance because it didn't happen. Now let's look at the next one, okay? This one's the one with the most molecules right here, and the most atoms, I mean. So when we look at it, we can see that chlorine is an odd number here, but it's an even number here. Is that ever gonna balance as is?
No, because one is odd and one is even.
Right, it'll never happen, right? So we need to make one even by putting a 2 in front of it, and then it'll happen, right?
Mhm.
If we put that, that becomes 6. Now we can put a 3 in front of this one for it to become 6. And now you can see that the aluminum gets the 2, right? And the copper gets the 3. See how I just left it at the end to balance those two? Because if I had started by balancing that, I would have probably messed up. Maybe not in this particular one, but I would have. All right, the next one that we have is this one, right? That's the most complicated one of the 3. And if we look at it, we can see the CO3 is balanced, but the lithium is not. The zinc is balanced, the carbonate's balanced. Everybody's balanced except lithium, so all we need is a 2 right here. See? All right, for this one, the most complicated is going to be the lithium hydroxide. And we need to compare it against the other side. So there's a hydrogen gas here, which is H2, but this lithium is by itself, which means that this side is odd and this side's even. So we know what to do with those, right? And we put a 2 in front of it. And that 2 means that we now have 2 oxygens, 2 hydrogens, and 2 more hydrogens on this side. So that means it's 4. So we need a 2 right here and a 2 right here, just to make sure that we have, see?
Mm.
The last one, okay, again, odd and even, you see that? And you've got to look at always look at the odd and even business, because they are not going to balance otherwise. So you're going to put a 2 in front of there. And that means we need 3 oxygens, right? And 4 aluminums. Why 4? Because you got 2 times 2, right? Right, exactly. And that's how you do it. All right. So, and let's see, here's the balancing that it's done on the computer itself. So here it goes. See, you can see that it's matching. And there, now let me erase all that. Okay, so this is a very easy little reaction. It's known as a combustion reaction, or you can also call it a synthesis reaction. Combustion because, as you know, anything that needs to burn needs oxygen, right? And so whenever you see a metal or any other thing with oxygen, that means chances are you are burning it. In this case, you are burning magnesium ribbon and producing magnesium oxide. Magnesium ribbon is a very silvery, like looks like a ribbon, but a ribbon of metal. So it's hard, you know, and not hard, but it's very pliable. And when you heat it and it becomes magnesium oxide, you would know immediately you had a chemical reaction happen, because it looks like ashes. It's very, it's like powdery almost. I mean, if you touch it, it becomes powder. So whereas the magnesium itself is not. So when you look at this one, you know it's imbalanced by just looking at it. You can kind of see the representation. There's not enough O's, right? On the product side. The product side is the right. The reactant side is the left. All right. So we can do the inventory and see. And that is definitely not balanced. So this is what I call by inspection. So basically, you're just looking and you know that you need a 2 in front of the MgO and a 2 in front of the Mg. And that's a correct balance. Now, some people might look like they balance like this, That is incorrect because you must use whole numbers, okay? You can't use half, you can't use 0.5, you can't use anything like that. It has to be a whole number. And this one is wrong because you played God right here. Magnesium never attaches to itself. You see that? This right here will not happen, this Mg2. All right, now, that is also incorrect because you could just as easily simplify it. And it's just like the one on top. You see that? So it's incorrect because it needs to be in the lowest whole number ratio possible. Okay. And 4:2:4 is not the lowest. 2:1:2 is, right? All right. So let's clear that and let's keep going. So in order for it to be correct, you have to have these rules. Okay. You cannot change anything. You can only add coefficients. And coefficients are in front of the molecules or the atoms as may be. Okay, now, one of the things to do is to always look at the polyatomic ions as a single entity, like they're one thing, and you balance them together if they're the same on the other side. Sometimes they break up and you cannot do that, and you will see an example of that later. But for now, okay, so what to do with this one? Okay, let's look at it. Definitely the most complicated one is going to be this guy, right? So comparing it to the other side, what would you do?
Let's see. When you add a 5 to oxygen 2?
That is correct. And that is all you need, right? Because the 4 is already balanced.
Mm-hmm.
There you go. Okay. Let's go to the next one. All right. What about this one? All right. One more time. I'm going to give you hints. This is the most complicated one of the three because it has 3 types of atoms, right? Whereas the other ones either have 1 or 2. So looking at it, what do you see that needs to be done?
If you put, when you put a 2 in front of it?
Yes, because it is an odd number of hydrogens, right? And on the other side, it's an even number.
Mm-hmm.
Okay, so when you did that, now you have 2 here and 2 here. So that becomes 4 hydrogens. How many do we have on the right? I mean,
And
on
you
the
put,
left, sorry.
you put a 2 there.
A 2 there. And that becomes pretty much balanced except for one thing. Who's missing?
Lithium. You got to put a 2 in front of lithium.
That's right. Perfect. And now it's balanced, you see? So it is a thing about doing the whole number ratio as best as possible and also trying to make sure that both sides are even, right? All right, this one looks complicated. And yes, I will definitely spotlight that first molecule because that's the most complicated, right? This one right here. So in order to look at that, you have to compare the other side. And it's very beneficial to compare everything that's on here. So you notice the NO3, here there's 3 of them. Here there's only 1. The bismuth here, there's 1. Here there's 2. So the first thing we need to do is to put a 2 in front of that bismuth. Now the bismuth nitrate, because now it's balanced, the bismuth. You see that? Now you got 2 times 3 is 6. So we need a 6 in front of this one. You see that?
Mm-hmm.
And now there's 6 potassiums and here there's only 2. So we need a 3 in front of that one. And now everybody's balanced, even the sulfur balance now. So that's how you do it. Yeah, if you hadn't compared, look what would have happened. Let me undo the ones I just did. Okay, so let's say you had, oops, redo that one. If you hadn't compared it, you would have started by balancing this guy, right? Because you said, oh, that's got 3 and this one's got 3. And then you would have gone, oh, and then this one needs a, oh, wait a minute. This one's got a 2. Oh, so let me go erase. You see what I'm doing?
Right.
And then you would have gone, oh, I need this one. I need this one to be 6 now, right? Because that one's a 2. So now this one's a 3. And there you go. You arrived at the same thing? Not yet. You still got 2 to do here, right? And there you go. Now you're done. But see how we had to erase because we didn't compare first? And that's the main thing. You've got to learn to compare it. We arrived at the same thing. I'm not saying don't do it this way, but it wasn't it easier to just look at everything and then not have to change anything? So that's what you want. You want to try to be as efficient, I guess we could call it, as possible. All right, so let's do the next one. Okay, this one is known as a combustion reaction. How do we know it's a combustion? Anything that burns in oxygen. In this case, this is a hydrocarbon because it has carbon and hydrogen, so it's known as hydrocarbon. Burning in oxygen, as a matter of fact, this is ethane gas. And it always produces carbon dioxide and water. So whenever you have a gas burning, like a hydrocarbon gas burning, it's going to be carbon dioxide and water. Even if it's an alcohol, it's going to be carbon dioxide and water. It doesn't matter. But in this case, this is ethane. So when we look at it, the tip that I'm going to give you is what I always do. I look at this number right here, and you'll see why. And then I say to myself, is that going to be an even or an odd number when I half it? Because you need to half it because of this, right? And that's an odd number. If it's an odd number, then that means this is going to stay odd, right? And look over here on this side, it's even. So you immediately double it, okay? When you immediately double it, then you don't have to go back and change things. You put a 4 right there, right? Because 2 times 2 is 4. 2 times 6 is 12, so that means we need a 6 right here. Now, when you add these two up, I usually like to do 4 times 2 is 8, plus 6 times 1 is 6. That gives me a total of 14, right? And 14 divided by 2 is 7. See? That's how I do it. Because it just makes it faster if you do the math, you know. All right, and that's how you have to always check. If you see a hydrocarbon, always check this number right here. If that becomes an even number, don't worry about doubling it. But if it's an odd number, you have to double. Because otherwise, look what would have happened. So now
Right.
here all drawings. I'm just gonna show you what would have happened if we had started. Oops, there we go. I did way too many. All right, so here, if we're just going, okay, so there's 6 of those, so we need to put a 3 here, and there's 2 of those, so we need to put a 2 there. Now we got 2 plus 2 is 4 plus 3 is 7, and doesn't divide. 7 divided into 2 is 3.5, right? And what did we say we cannot have?
You gotta have whole numbers.
Exactly. So that means we have to multiply everybody times 2 now. So this become 2, right? Oops, that was an ugly 2. This one will become 7, right? This one become 4, and this one becomes 6, which is what we started with to begin with.
Right.
See? So it's best to just check this little hydrogen and say, oh, yeah, it definitely needs to be doubled. And then life becomes very easy as far as that goes. And there's a 7 right here. And there you go. Okay. So that is the main 3 things that I can kind of give you pointers on. Now we're going to have, now there are, oh, and this is how they're all balanced now, but yeah. And see how they did that? See, they did that 3.5. You see that? And now they're going, oh, we need to double. Well, why bother doing that step when you can just check first, right? All right, so now let's clear all that drawing. Now, all these equations are already balanced, okay? So if you ever want to practice these, you can practice by going back and erasing, you know, like rewriting these or printing this out and just blocking out this little piece. If you ever want to, let's see, what I usually do when I'm doing something like this is I insert a block on top of it and print it that way. And actually it gives you the block so you can put your number into. So, and that's the best way to do it on that one. Let's see. But there's a lot of equations that you can practice with. You see that? Lots. But they're all balanced already. But these aren't. So we're going to do these. All right. So you guys tell me. I'm going to go ahead and escape because that way it makes my life easier as far as inputting the numbers rather than me having to use my very poor drawing skills. I can actually type into it. And you guys can see that okay, right?
Yeah.
Okay. All right. So the most complicated one would be which one?
Would it be E?
This, no, I'm talking about on the A molecule, on the A equation.
1 to the farthest right.
Yes, that one, right. So comparing it, right, you can see that the hydrogen's odd, right? And here it's even. So it'll never balance unless we put a 2 right there, right?
Mm-hmm.
Now what to do?
You got to also add a 2 to lithium.
Yeah, but that's last.
And a 2 to oxygen.
Yes, that's where we need it first. Why last? Because it's by itself, right? So we want to make sure that we have already balanced everybody before we do that. And yes, that would be correct. But if you start there, chances are, you know, you never know. Okay,
Right.
what about the next one? Obviously, this is the most complicated one, right? Or complex, or whatever you want to call it.
Put a 5 in front of,
The O2.
yes.
Okay. All right. And this one, remember, that's one of those that you check the 6 divided by 2. It's odd number, so you start there. Now what to do?
Gotta put a 4 right there, right?
4 in the carbon dioxide. Yep. And a what?
3.
3?
3.
Well, it's 12 because it's 6
Oh,
times
yeah.
2. So it's a 6. Oops, not there, not 46. Sorry, I meant to click and it didn't click there. Okay, now here's where you have to add both of these. 4 times 2 is 8, plus 6 is 14, divided by 2 is
7.
7. Yes, there you go. Now this next one, okay, so everybody goes, oh, they're all as complicated as each other, pretty much, except for the O2. So the O2 we're going to leave alone for now. You can go with whichever one you want. The way I see it, the carbon and the sulfur are making up this one, right? And they all have oxygen with it. So I would start with this guy only because oxygen's already here and it's by itself. So looking at that, I can see that we have how many sulfurs?
2.
2. So we need 2 in here, right? Now you see that's pretty much balanced except for the oxygen now. So you got 2 times 2 is 4 plus 2 is 6 divided by 2 is
What, 3?
3. And now you're balanced, you see?
Mm-hmm.
Okay, what about this next one? which one? Well, obviously it's this one, right? Because it's got five atoms and two different things. So this would be the one I would start with. Okay, looking at it, what do you see that you need to do to the left? To the right, I mean, excuse me. I'm saying left, I'm saying right, and then look at the left. So checking both of these. And it doesn't really matter which one you start with necessarily because they're all going to be different. So looking at the AS, you have a 2 here, you have 1. Looking at the S, you have a 3 here, you have 1. So what do you do? Which one do we want to start with? Either one will lead you to the right number.
Would you put a 2 there?
A 2 in the ASCl3? Yes. Because that now the AS is balanced. You see that? The Cl is it's not by itself, but it's with hydrogen. So we haven't finished balancing this guy, so I wouldn't touch it yet. You see that? Okay, so now you got a 3 here, right? And a 1 there. So we need a 3 here, right? Now, how many hydrogens do we need?
6.
And that means we also need 6 chlorines if you look. Because 2 times
Exactly.
3 is 6. Yeah, see? So either one would have taken you the right path. Yeah, that's what I was telling you in this case. But not always. So you have to watch that. Okay, so the most complex molecule is this one right here, the FeNO3, right? Oops, sorry. Stop it. Okay, there we go. And we're comparing it against the other side. Okay, so the iron is balanced, but the NO3 is not. So we need a 3 here, right? That made 3 silvers. So we need a 3 there. And look at that, that balanced the chlorine too. You see that? See, sometimes molecules balance themselves at the end. Sometimes, not always. Like the oxygen hardly ever balances itself, but the other ones do. So that's the main thing. Okay, looking at this one, you can see that this is an odd, that's an even, because the KCl is already balanced. So we can't go by it, but this one's not. So that's an odd, so we need a 2 in front of it. And that becomes a 2 in front of this one, right? And now 2 times 3 is 6, so we need a 3 in front of that one. All right, what would you do with H?
When you put like a 3 in front of the SO2.
A 3 in front of this one?
Yes, ma'am. And then a 2 in front of the.
Okay, yeah. Yeah, that way it becomes 6. Now, are we balanced as far as the oxygen goes?
No, because you have that'll be 6. Yeah, it's 6. Yeah.
Oh, but you have extra 2 right here.
Oh.
This is where it gets complicated. You notice that you put a 3 in front of that. Now the S is not balanced. You see that? It needs to be a 2. You see that?
Yeah.
And now it's balanced because now you have 6 oxygens also. Because you got the 2 times 2 over here and plus 2 more. You see? Okay.
Oh, I see what you're saying.
Yep. It's just like I said, it gets a little complicated sometimes, but if you had and you had a right idea, but you started wrong because you started by balancing this guy. You always balance the odd one first. Started here. See, if you had started here, right, you would have said, oh, 2 there. Then obviously I got to have a 2 here, right? Because you got 2 sulfurs. And then you would have gone 2 times 3 is 6, 4 and 2 is 6. Oh, I'm balanced. See? So always start with the bigger one first, which is this guy. And now you see why.
Right.
All righty, so that's all of the ones we have, and here's the answer. So they're, they're already balanced here, so all of them. So now we are going to go to our tutorial, and that is this one. And that's the one I had printed for you guys, and then I realized I didn't need to print them, but I'll give them to you when I see you again Tuesday, next Tuesday. All right, so enable editing. All right, and let me make it bigger. Okay. All right, so when you look at this, you can see that this is the one we just did. This is the ethane burning in oxygen and becomes carbon dioxide in steam, in water, so water vapor. So this right here is the one I was telling you about, that is a combustion reaction. And you notice they're gonna go through the same mistake again because they did the 3.5 again, right? Because they didn't double this one to begin with. If they had started by doubling that, that would have been avoided. So you always check your hydrogen on your hydrocarbons, okay? All right. This next thing is another tip. It says treat standard groups as an item. So basically, if you see sulfate, right? Here you have 1, 1, 3, and 2. So just treat them as one thing, okay? They're not going to change unless they do. And I'm saying they're not going to change unless they do. That sounded redundant, but look at here. In this case, you see this one didn't change, right? You got an SO4 and you got an SO4, right? So that means, and this is one of the things that I like, is if your brain gets too laden with all these numbers and all these things, if you substitute the SO4 for X, like this, it makes life easier to look at it anyway. And so you said an X3 and an X. Oh, I need a 3 in front of that, right? Immediately you would know that. And you put it on there. And then you go, oh, now I have 3 hydrogens, so I need 3 times 2 is 6. So I need another 3 in front of that. And that balanced everybody, you see? All righty. So, and then you just return everybody back from the X method. This is what I call the XY method, and sometimes it works really well. Now, you notice the next tip, it says balance the elements last. So you don't start by balancing this hydrogen with this carbon and say 4 right here, right? You don't say 4 there, because if you start by doing that, oh, actually 4, no, not 4, 1 like 3 there, right? Because that's going to change because the oxygen is not balanced. You see that? So you can't start there. You need to start with the other things, like in this case here, right? That's where I would start, because the oxygen's 1 on this side. You see that? And now I see 2 and 2 is 2 times 2 is 4 plus 4, that's 8. So we can put a 4 right there, and that should do it. That should have balanced us. See, they went through all of it, and there it is. Because they didn't start, they started with the wrong thing first. They had to go back, and that's what they're trying to show you. All right, so the summary for this, and I would not do this one. I do not like doing this. I would exclude that one out of my summary. But it says you may only put numbers in front of molecules, never altering the formula itself. Like, you cannot do that. That, like I said, that's playing God, because you're making molecules that weren't there to begin. Chemistry God, you know, you're doing something that shouldn't be. All right, balance the complicated molecules with lots of different atoms first. Putting numbers in front of these may mess up other molecules. So use the simpler molecules to adjust those major changes. Then it says, if you recognize the atoms making up a standard group, such as sulfate, nitrate, phosphate, ammonium, etc., that survived unscathed throughout the chemical reaction, then treat them as an indivisible item to be balanced as a whole. You see that? This makes life easier and it helps understanding of chemistry. It really does. And then leave molecules representing elements until last, right there. That means that any numbers you put in front of all those other molecules will not unbalance any other molecule. You see, so by then you've already balanced everybody. And this is the next thing, and this is in your book, in your Connect also. You're going to make an equation complete, you need to put what state of matter the things are in, solid, liquid, gas, or aqueous. And here's, the representation of each one. And like right here, see, you could say solid magnesium and oxygen gas makes solid magnesium oxide. You see that? And you could say that, or you could say magnesium metal, which is also a solid, right? And here's some equations that we need to balance. All right. So I want you guys to balance this first one and then tell me what you would do. And that's the arrows missing from this one. For some reason, it always is. I'm just going to insert it myself. Let's see if I can. I don't know if I can, though. I don't know. It might not let me. Yeah. Okay. There. Now you see it. All right. So you know which one's the products, which one's the reactants. All right. So you balance these 4 and let me know.
When you put like a 2 in NH3.
2 in front of NH3. Okay. What? Oh, the macros are. I see. It said that the macros aren't going to be activated. Oh, man. You did not let me activate my macros?
Mm.
Yeah, I can't. Okay,
That's-
I'll just put it in front of here. I think I can. Let me see. 2. Nope, it's not letting me.
Yeah, it's still, I can't see it.
Yeah, I'm just going to have to draw it with my ugly drawings. Sorry.
Mm.
There, 2. Now what? Hopefully.
So in front of that, when you put a 3 there, that way they'll balance out. A 3 in front of the H2.
The H2. See, it won't let me. I have to draw it in front. Come on, why are you being like this? Put a 3 there. There. And that was a 2 up here. So sorry, but we left the 2 behind.
That's fine.
Because I had to get rid of the little mark that wouldn't let me put it on there. Okay, so that's balanced. All right, what about the next one? See, this is where I told you you need to do that little trick. Remember the hydrogen? You need to check on it first. So divide it by 2, right? And is it odd or even when you divide 8 by 2?
It'll be even.
So that means you don't have to double, you see?
Mm-hmm.
So then you can just start balancing. And remember, oxygen last. So balance what's there. Tell me what you do. I'm just going to probably put it right on top of it. Hopefully it'll work.
When you put a 4 right there.
A 4 on the, see, it did let me. Okay.
And a 3 right there.
And a 3 right here.
Yes.
All right. And now what?
6.
Remember, you have to add them. So 3 times 2 is 6, right? That's the the carbon dioxide oxygens, and then plus 4,
Be 10, right?
10. So that how many do we put in front of the oxygen?
5.
That's right, because 5 times 2 is 10. There you go.
Mhm.
See, that's one of the, everybody says this is one of the hardest things to balance. And to me, it's so easy if you just check that one thing. Makes it so much easier. All right, what about these? What do you see? Which one's the one you would look at? And compare to the others.
When we start with the aluminum 2 and oxygen 3 first.
Yes, so that's called aluminum oxide, and we're looking at it, right? And comparing to everybody else. Okay, we have 2 aluminums, but we do not do that one because aluminum's by itself. So the oxygen is what we want to check. Here there's a 3 and here's a 1, so they're both odd. So it's okay to put the number in front of it, right?
Mhm.
And that would be a 3. Why a 3? Because we want 3 oxygens. All right, now the copper is okay, see? And you can put a 3 in front of that, and what is left? Oops. Ah. I dragged, I'm trying to get it out of the way, and I dragged it. There we go. What?
So only thing
Aluminum.
left is aluminum, and you can put 2 on that side.
Yeah, that is correct. And there you go.
Okay.
All balanced. You see that? You guys are getting good. All right, let's go next page. Oh, I need my mouse. Okay, next page. The next one's not as easy. This baby is a, yeah,
So the one on the right would be the largest, right?
no doubt. That is a big molecule. So we're looking at this one and comparing. Oops. Okay, so S4O6. And on this side, we have S2O3. So it's obvious what to do, right? No, not so obvious.
Yeah, put a 2. You put a
Okay, a 2 right there, right? And that gives us not quite balanced yet. All right, so how many sodiums do we have? 2 times 2 is 4, right? And here we have 2 and 1. So we need a
2.
2 right there. Yes, ma'am. And that balanced our iodine too. You see that?
yeah, was yeah.
Mm-hmm. All right. What about this next one? How do we balance it?
Put a 2 in front of the KOH.
Okay. That's because the other one is K2, right? And
Mhm.
did that balance us? It did. That's it. Because you notice there's two potassiums, 2 oxygens, and 2 hydrogens. Yep, it's balanced.
All right.
All right. This is one of those that if you focus yourself on all of these elements, your mind's gonna go, oh my God. But if you just substitute it by an X, and that would be an X3, right? And an X here, and a Y here, and a Y6 here, right? This is just for your mind to simplify what you're looking at. All right, that's a 6. That's an ugly end. Okay, there we go. That's a better 6, but it still looks like a music note. But that's a 6 anyway. So if now you can kind of look at it better, can't you? All right, so look at here. I'm comparing this big guy to everybody else. All right, so I see K3. Obviously, there's a K2 here, so we don't want to mess with that one. But there's an Fe here. And how many are there over here?
2.
So that means we need a 2 in front of this, right? To balance the iron. And now, see, because we did that, because we compared, we won't have to erase. All right, now that you have that, You notice that we have a Y6 that we're multiplying times 2. So that gives you 12, yes?
Correct.
And how many Y's do we have here?
You just have one.
So we need a 12.
Right.
Okay. Now, and believe it or not, that's almost, not quite yet, because we have an X and an X3, right? And the X3 needs a 3 in front of it, right? Right here. Okay, now it should be balanced. Let's see. We have 6 potassiums and 6 potassiums. That makes 12, right? That's correct. We have 6 Ys and here, 6 times 2, 12, and 12 Ys. That's correct. We have 2 irons, and 3 SO4s and 3 SO4s. There you go. It's balanced. But you know, if you'd have started by balancing the SEN first without looking at the iron, you would have had to double everybody because it would have never matched. You see that?
Mm-hmm.
So that's where you have to always start with the most complicated one and check it out. Compare it against everybody else, because all the elements. And the reason I didn't start with the K is because there's a K here too, and we can't do that. But the FE, see, there's only one, but here there's 2. So we said, we definitely need 2 here, right? Because there's only one FE. So that's the one that you focus on. And then everything else seems to fall in place. All right, so you guys do the next one. Obviously, it's the one on the left that we would look at, right? Because that's like the most complicated of all. And in this case, you notice the ammonia and the ammonium in the carbonate ion did not survive on the other side, right? They decomposed, and this is known as a decomposition reaction, by the way. They actually broke apart. You see that? So we cannot balance it that way. We have to balance it a different way. We have to think of them being separate now. So how many nitrogens do we have on both sides? That's how I usually start. I start with the first one.
So if it's parentheses, you'll have 2 nitrogens on the left side.
Right. And how many on the right?
You just have 1 over there.
Okay, so then you know, because that's the only nitrogen, right? That we need
Right.
2 right there. But the oxygens are split. You see, this is why we don't start with them. All right, is carbon balanced? Yep, check. Is oxygen balanced? 3 here, 2 and 1 is, there you go.
Yeah.
And then hydrogen is 2 times 3 is 6, plus 2 is 8, and you had 8 right here. So yeah, that's all it took. Yeah, that one was an easy one without even, it didn't look easy, did it?
No.
Yeah.
Not at all.
It sure didn't, but it was. All right, so let's do, oops. Sorry, I'm trying to pull this up with my finger and instead I made a big old smear. All right, because my mouse didn't take.
Dr. Valdez, you must be working on an iPad or something.
No, it's my touch screen computer that I have. I love touch screen. I wish I had an iPad. That's what I need. So that whenever I make my 2s, they look like 2s. Because then I'd have a stylus. Instead of looking like who knows what those things are. All right. So
you better check that out, that Black Friday sale.
Yeah. I should. All right, so this is an easy one. It says the burning of hydrogen gas in oxygen to form steam. Okay, so this can be construed as one of 2 things. It's either a synthesis reaction because you're putting 2 things together into one, or it can be a burning, like it says here, burning, right? Because it's a combustion reaction, because usually when you have a combustion, you have an element plus oxygen, something plus oxygen, And the products always contain oxygen, and that meets those qualifications. So looking at it, what would you do?
Hmm. Start at the end
At the end,
where the
everybody-
arrow is.
Uh-huh. What do we do?
I want to say 2.
You're correct. Because the oxygen, there's my weird too, and the oxygen right there now is balanced, you see? But now the
Mhm.
hydrogen needs something, right?
Need to put a 2 over there.
Yep.
Yeah.
And that is it. You're done. All right, what about this one?
Add a 2 to the right side.
Add a 2 to the right side. And you started beautifully, because most people would have started with the magnesium and had to go back. You never start with the one that is single, right?
You
learned
know,
that
I know.
lesson.
You put me on blast earlier, so that's how I knew. Can you put
Yep,
a
but
3
see,
in
but
front of
now
it?
you see why, right? Because it makes sense, doesn't it?
And then you put a 3 in front of magnesium.
3 or a 6?
Oh, no, 6. I'm sorry. 2
Yep.
3 6.
2 times 3. There you go. See, balanced. And the last one,
Will we start with the parentheses first?
yes, I would. Because they're both NO3s, so yes. If you had decomposed, you can't, but this one didn't, so. And this is a double displacement reaction, by the way. Because
would
you
you
notice
put-
that the calcium is switching places with the silver. You see that?
Yes, ma'am.
Mm-hmm.
So would you put like a 2 in front of the AG NO3?
Yes, that's where I would start for sure. And now what?
You put a 2 in front of the AgCl.
Yep. And guess what? That just balanced your chlorines too.
Yes, ma'am.
See that? Sometimes they just balance each other, and they work beautifully. All right, so that was it for the day. Now there is another sheet, and we can sit here and practice if you want. I know that it's almost time to go, or we can just leave it out and let you do it, and then bring it on Tuesday back and say, oh, I need my mouse. That's why I can't do anything. All right, this is the sheet right here. Sheet. Nope. Apparently, this is the sheet I want right there. Okay, there we go. This one. All right.
And it's located in chemical equations 3.
Yes, this is the balancing practice, I think is what it's called.
Yes, ma'am. I'll
Okay.
just probably
You say
print it. I didn't work on it and bring it
So
back.
yeah, like I said, you can either do a couple here with me if there's 1 or 2 that you might be afraid of. Do not be afraid of number 6. You know, you have the tools.
Mhm.
That's gonna go high. That if you want to do, we can do that one together, because that's
Yeah.
that's gonna kick your butt. It
Yeah,
really
we
is.
can.
That is well.
Yeah, she's already. I can see that. All right. So remember the tip I gave you. Look at what? The H, right? Because this is a hydrocarbon burning in oxygen. You see that? Because you got the CH, right? And then the
Mhm.
oxygen, and then the products are always carbon dioxide and water. So look at that. Divided by 2, is that an even or an odd number?
It'll be an odd number.
So that
It'll be
means we
9.
start right here. Sorry, I need to enable editing. I didn't see that. Okay, now go back to it. All right, so we start with a 2 there, right? Because we're saying we know that we're going to need an even number here, and that's half, right, of that. So if we put a 9 here, that would have been a 9 there, you see? So now it's an 18, see?
Excuse me.
Right?
Right.
Yes.
And then here in front of the carbon, what do we put?
16.
That's correct. Now you see, this is what I was telling you. This is a huge number. So 16 times 2 is 32. Hold on, let me, right? 16 times 2
Correct.
is 32.
32.
That's not what I want.
Correct.
Clear that. I need a little pen. 32. And then we have 18, right? On this side. How much is that?
50.
Okay, so what do we put in front of the oxygen now?
25.
That is correct. You see why we did that? Look how huge these numbers are.
Mm-hmm.
Yeah, the larger the hydrocarbon, the more oxygens and carbons you're going to need. And water, all of these, they're all going to be huge. So you have to always do this.
Okay.
Always balance the ones that aren't together. You know, see, you balance the oxygen last, because if you would have started with it, you would have had a really weird number. And you would have been totally lost. And see, that's the main thing. If you start correctly, basically things kind of guide you as to what to do, you know, if you pay attention enough to look at it. Now, if you had done this with the other method that I told you about, this would have been a nightmare, I think. I mean, that's just my opinion. But we can check. I mean, a lot of people go, why don't we do it the other way? Okay, let's try it. Let's try it. And you'll see. And we're just going to start with carbon. Oops, enter. Tab. Hydrogen. And that's all that's in here, by the way. It's oxygen and carbon and hydrogen. That's it. Oops. And that's an oxygen, right? Okay. So let's take these off and try to balance it the other way. Yeah, I bet you it's going to be hard as heck. Because it is. It just is. All right, so carbons on one side is 8, right? On the other side is 1. On this side, we have 18 hydrogens. On this side, we have 2. On this side, we have 2. And on this side, we have 2 plus 1. And the reason I say 2 plus 1, like I said, it's because, oops, come on, tab there. 2 plus 1. Because what we do to this one, we don't do to this one, right? So that's why I always put 2 plus 1. I think it helps, at least if you're trying to do this method, it helps you. Okay, so see here, you would probably start by going, okay, I need 8 carbons, right? That's what you would say in 8 and 9, right? Immediately, you can see that. All right, so if you start with that, you would say, I need 8 of these. And that means this becomes 16, right? And then I need, you would say, I need 9 of these, right? Because by multiplying that, right, you are doing this. Oh, and that became a 2, sorry. I forgot that one. All right, 9 of those. That is 18 here, right? And see, that's balancing. But look at this one. That's not ever going to balance. You see that?
All right.
Oh, and that was an 8. I don't know why I put it there. Sorry. There we go. I don't know why I put it 2. I was crazy. All right, so there. See, everything looks balanced except the oxygen, but can you ever balance that oxygen? Is there a number you can multiply it by to make, what is it? 20? No, what is that? 25, yeah, 25. No, right?
25.
Yeah, you can't. It would be 12.5, right? That's what you would have to multiply this by. See? To make this 25, right? But is that allowed? No. So now you
No.
have to go here and go, okay, that's a 2. That's going to be 25. That's going to be 16. And that's going to be 18. And isn't that what we just did already? So you can balance it this way, but it takes more time. You see that? So if you want to do it this way, that's your choice. I mean, I advocate for the other one because everybody always turns to the other method after trying this one in learning how to look at things. But if you want to start this way, that's another way, okay? And it does lead you the right path, obviously, right? But you would have to actually make sure that you change everything. Like I didn't change that carbon. You saw that. I skipped that carbon, and that was not a good thing. So you've got to make sure that whenever you change anything up here, you change it down here too. So now that did it. All right, any questions from anybody? Oh, you know what? I meant to show you something, and this I don't want to forget, because a lot of people don't know how to enter these. And I'm going to show you on your assignments how to enter this stuff. Okay, hold on. Let me go back to connect. I passed it. And otherwise, you're going to be going, oh my gosh, I can't get this right if I don't show you this, because it is something important. On the next assignment that we have, I think it's the one that is the plain assignment, not the application. I think might be the application. I don't know. Let me see which one it is. And by the way, I don't know if you noticed, but everything is going to now be open for you. That's another thing I meant to show you, that I'm going to open everything for you, including first this. This is your test, which you can take over the break, right? And I'm going to, okay, I need to get my mouse. There we go. This thing is getting on my nerves because it's blocking everything. Sorry. It's, when I do Zoom and I have these little things in front of me, I've got a bunch of stuff, but it blocks me from what I want to do. So it's kind of hard to see anything. Okay, there we go. Now I can do it. All right, so manage dates. And remember that is, it's gonna be due on the, I guess Sunday. I'm gonna make it be due Sunday. That way you got enough time to do it, since I know it's the holiday. But Sunday should be, you should be full of turkey by then and ready to work. All right, so that's when that test will be due. Okay, but I now have to go do the extension. So I gotta save that and go back.
We said chapter 8 assessment is the one that's doing a 27.
Yes, chapter
Okay.
8. So I am going to go back to it again. This is how it's done. This is crazy. But if I want to do an extension for you guys, which I always do, by the way, I extend the amount of chances you get, because this will never hurt you. This is only meant to help. And I think by you taking something over that you missed, you're learning. So this is the reason why I have the extensions. I gotta take every single person here, even if they're not coming. Okay, and then due on the 17th, 27th, and we need 3 attempts.
And that's for chapter 8.
That's for chapter 8, yes. All right, now the rest of them I'm going to open for you until the 18th, until the 8th of December. Every single thing that's left, okay? The reason I'm doing that is that way you can start at your own pace, but you know, there's no reading assignment, right? You notice I blocked it out. So it's just your, and even the tests. The only thing I'm not going to do is the final. That one I'm going to open when it's ready, okay?
Cool.
All right, so everything else is going to be open for you until the 8th.
So think, what are you doing with those things that you're
Not
checking,
it.
Dr. Valdez?
No. I did not mean to do that. I'm sorry. I'm going to open them. That's what I'm doing. I'm opening them until the 8th of November. I'm December. Sorry, not November. That would be going in the past.
Is it
There
the
we go.
18th or the 8th?
Yeah, the 8th. Yeah. The 8th of
Okay,
December.
that's it.
See, all of that, it says 8th now. You see that? Not the reading assignments, because like I said, I'm not doing those, but everything except the final right, says that. So the final stuff. All right. Now let's go back and let me show you what I was talking about. When you're doing, and I'm going to check both assignments, but I think it's the application problem. So I'm going to go there first. And I'm going to do preview. And yeah, see, writing balanced equations. This is it. Okay, you notice how it's telling you nitrogen hydride, right? NaH. Oops, not like that. NaH. There we go. And you notice it tells you is a added solid. You see that? So you see this S right here? You're going to put solid afterwards. Okay, and then you're going to say plus water. So you know that's H2O, and you know water is liquid, right? Oops. H2, sorry, 2 goes here. You got to click on that, put the 2. And in this case, since I have a laptop, I get these little up arrows. In your computer, if you have a keyboard with up arrows, you will not get that. So you bring it up, and then you put your O, and then you have liquid, right? Okay, and that's going to yield, it says sodium hydroxide, right? You see that? And it says aqueous. So this one, right? Plus hydrogen gas. And remember, hydrogen is a diatomic. So that means you always have to put it as 2. And then bring it up again before you put the G. And there you go. All right, and that should do it. And this one is actually balanced, isn't it? Yeah, it is. All right, so that there's no need to balance that one. All right, now this one says aluminum metal, so Al, and that's going to be solid, plus chlorine gas, right? So Cl, oops, Cl2, because this is chlorine, and chlorine is diatomic. And then go back up and put G for gas, right? Yields aluminum chloride. It says Al, oops, Al, Cl, Cl3. And this, once again, you need your keypad to go down. So 3, bring it back up, and it says solid. You see that? Okay, so solid. Boom, there. Now, this isn't balanced, so let's balance. That would be, we need 3 of these, right? We need 2 of those. So that means we need 2 of these and 3 of these. Okay, that should be correct. Oh, you know, the reason why it's not, this one didn't like this right here. It didn't like this thing being in here. And I did bring it back up, but it just didn't do it. See, for some reason,
You might have to erase the last portion and redo it.
Yeah, I'm gonna have to erase this, but it won't let me. I have to start over again. Yeah, trash it. Okay, here we go again. Na H solid, it says, right? Plus, so you got to be careful how you put it. That's water, so H, and then we got the 2, and then we go back up, got the O, oops, not that O, this O, and then we got the liquid. And then that becomes sodium hydroxide aqueous plus hydrogen gas, right? Go back up and do G. There we go. Oops, not this G, this G. All right, there. Okay, and that one, I think it's balanced already. Let's see. Yeah, that's it. Okay, now it should be okay. See, it was just that extra little blank that was on there. You got to watch that. So if you get one, might as well start over again. And there you are. So that's how you enter it. You see how it's pretty simple, but you got to know how to do it, right?
Right. Dr. Badez, so we should be working on chapter 6 assignments just to be on.
5. Oh, if you're not done with.
I mean 5.
Yeah,
If we're done with
okay.
8, the next one was 5, right?
Yes, well, I know that you're always ahead of people. That's why I was saying maybe. I don't know.
I'm just trying to finish it all.
Yeah, this is 5. So that's what
Okay.
you just have to make sure that you put all these little symbols in there because they're describing it to you. See how it says added to water, hydrogen gas is released, sodium aqueous. See, so it's telling you everything that you need to add on there. All right. Let's see what else. There was another one that somebody said, "Ooh, I don't understand this one." Let me see. There was one more that I'm going to show you. And there's one in here. I don't know what the heck they want because I haven't had enough time to look at it. But I'm sure you guys will get it. It's just I have not had time to look at it because I'm always doing something. So, wait, where do I exit? It's not letting me exit.
Let me
Okay.
see.
Home. I'm just gonna go home. It doesn't matter because it's not. I don't get a grade anyway. So even if it said, I don't know. It didn't give me. Maybe it's because I was previewing it. You know. All right. Chapter 5 again, and this one is the one. This one is actually pretty simple, except for one thing that I cannot understand. I don't understand what they want. Like I said, I haven't had time enough to look at it, but hopefully you'll figure it out. And if not, you can take a picture of the one as I go through. Cheat. No, actually, it'll give you the answer, right? But it won't be the same answer as yours. So it's not really cheating. It's just getting more of a hint. All right. In this case, the mass number relationships. Okay, this one's going to be interesting because it is one of the ones that we're going to look at last. So right here, you might want to take a picture of this one because you'll know what to put in there. Okay.
Right.
All right. You notice I'm being nice and letting you see everything here. All right, the next ones, they're pretty easy. This is just, okay, this is what I was talking about. I don't get it, okay? I have no clue what they want. Let me move, guys. Okay, so I really do not understand what it is they want. So the change and all this stuff, I haven't figured it out. Okay, they're balanced it that way, but basically what I want to know is what initial. So there's 1, 2, 3, 4 of those, right? And then there's 1, 2, 3, 4, 5 of those. So that's what I'm guessing that's what this is. And there's 0 of those made, right? There's SO3 on this side, right? That's what they're talking about. The change is on the initial is on the left, the change is on the right. So the change, do we have any SO2s left? See, it says 4 here, but you're subtracting 4 because you made 4, right? Here you had 5, but you have 3 left. So the change is 2, right? You use 2, right? I'm guessing. That gives you 3. And then this one, you made 4, 1, 2, 3, 4, and the end. So you got 4. It's what I'm guessing is what that's talking about. Now, how does that end up balancing it? I have no clue.
Dr. Berdes, could you go back to that first question one more
sure,
time?
sure. Let me, I gotta go back this way. All right. Yeah, because this is, there you go. Yeah, this is
I
one that we
appreciate it.
haven't yet seen, but we're about to. So, you know, it's not fair for you guys to get this question right now.
Right.
Okay, so next. But did you see how that kind of went? I mean, I kind of see this part, but I don't see where this comes from, the balancing part. I mean, I know how to balance it, obviously, but that's not what I'm saying, is that I don't understand where this have to do with this, you know?
Maybe they assume we just knew. I guess, when we get into that chapter with the PowerPoints, they might break it down, possibly.
Maybe this change right here makes it. I don't know. I don't get it. I don't know. I do not know. So no, I'm not even gonna guess. Not gonna guess on that one. So, and that's just the way it is. So just look at it. Obviously, you can fill this in. That's pretty easy. But what does it have to do with each other? I haven't figured it out yet. But you know how to balance, and you know how to look at different molecules up here, right there, and you can kind of see what's going on, right? So that part's not so bad. But this is the one. And there's another one just like it. So see, same thing. And I don't understand where this comes from, but okay. Okay, so in this case, it says select all of that represent the given balanced chemical equation. Okay, so when you are looking at it, you've got A2 and plus 2Bs. Okay, so as long as you have an A2 plus 2Bs and a 2AB on the other side, then you're good. So this one doesn't have, see, this one doesn't have an A2, but doesn't have 2Bs. You see that? Only has 1, so that one's out. This one is okay because you have A2, you have 1, and you have 2Bs at least. So you can make an AB and another AB, you see? So that one's okay. Even though there's leftovers, it doesn't matter. You're just looking at those two things. See this one, you made it. So yes, that's good. That one's a perfectly balanced equation right there. This one is, you have the A2s right here, and you need to make AB, and you got the 2Bs. So yeah, and then you made them. There you go. And you got one left over. That's fine. It's not balanced, but it says it can represent this. Yes, because you can have excess, right? So it's okay. You have it. That's good. Same thing with this one. It's the same thing. And there's like 4 of these, I think. No, pull 2 of 2. Never mind. They're just 2. And then, come on, let's go. Okay, this one, you know, because I've been talking about these solid, you know, what each one means. That's the coefficient, that's the reactants, that's the products, that's your gas, and that's your liquid. So those are all pretty easy to get. All right, this next one. This one you have to pick which ones show a chemical reaction. Obviously, this is a change in state from solid to gas, right? This one is not, because it changed. You see how you got two red ones together, 2 white ones together, but here you got 1 red and 2 whites together.
Mhm.
See, this is another chemical change, and that's another chemical change. So these are easy to tell. There's one that's not as easy to tell, and that's not these. These are easy. The next one, I think it's this one. Yes, this, no, not that one. That's it. No, there's another one. There's a 4th one. Okay, this is the balancing thing. And remember, I told you sometimes you're going to have to put the ones. They actually want you to put the 1. Even though we don't use the 1 in ours, because just having the K2SO4 there means that we have 1, right? But they want you to put the 1 so that you don't forget it, basically, like you don't neglect it. So they want to intentionally make you put that 1 in there. And then these, okay, these you're going to have to go to your book and look for solubility rules. And I'm going to show you this here in a minute. I'm going to go to the book myself. Okay, and show you how to look for it. So look for solubility rules, and I think that this book is searchable, right? So you just search right here, and we're gonna put solubility. Oh, come on, let me. It's not letting me because it hasn't finished loading. Huh? Why are you not letting me put my? It's still loading. That's why. I'm just faster than it is.
Mhm.
Just not letting me do anything yet. See how it says loading? Ah, nope, not yet. Oh, come on. It is slow. It's a big book. Wonder if it even typed what I just typed. Dang, this thing is slow. I know it's table.
It probably has something to do with Moodle.
Yeah, it's table 5 point something. Oh, come on. Oh my gosh. Look at this, 27%.
29 now.
Oh no, I'm just gonna, I'm gonna look for it myself. Probably be faster. Okay, so I'm gonna show you where they are and how you use them. That's the classes of reactions. That's our next thing that we're looking at is reaction types. But what I want you to look at is the solubility rules. And the reason we need them is because a certain type of reaction, and see, there's the same thing that I showed you earlier. That's that reactivity of metals. That's on page 192, I guess. Okay, so it's table 5 point something. I just gotta find it. Where are you, solubility rules? Ah, there we go, right here. Because it's after double displacement. See, if without these rules, you cannot answer those questions. So you need to look at these rules. You notice how it says Na, so sodium, potassium, and ammonium ion are soluble. You see that? Most. It says most. Then it gives you some, all nitrates and acetates are soluble. So anything you put with nitrate and acetate is going to be soluble. Most sulfates are soluble except for barium, strontium, lead, calcium, and magnesium, and silver. You see that? So these are the exceptions. And then most chlorides, bromides, and iodides are soluble except for silver, mercury, lead, and the other mercury. And then silver compounds are insoluble, except for this one, which is slightly soluble. which is acetate. Remember, acetates are always soluble. See, so there you go. That's why it's soluble. And then oxygen, peroxide and hydroxide are insoluble. You see that? Except for these, which are soluble. You see, slightly. And then you've got, well, actually, sodium hydroxide soluble too. Okay. Anyway, right here, sulfides are insoluble except for these. See, it's kind of gives you very detailed information here. All right, so if you go back to it, then you would know which ones to put on there, right? Because now, oh, well, where did you go? Oh, no, it kicked me out. Okay, let's go back. Oh, man, I can't stand it when it kicks me out. All right, so the solubles, the sulfates, come on. And the reason, like I said, you need to know is because there's reactions that will not happen if one of those things is not insoluble. So in order for it to happen, you have to have one product that precipitates or the reaction will not occur. And that's how you check. No, not application. Nope. That is not what I clicked on. I thought I didn't click on it. Maybe I did in my haste. Oh, man. Where are you? 5. This one. That's the one I want. Come on, baby. Open up. Slow. There it goes. All right. So now let's, I don't remember which one was I on? Do you remember? Was it like maybe 10? Let's look at 9.
It was 11.
11?
That's the last
Okay.
one that you stopped.
Yeah.
Mhm.
I'll just go 2 more. Okay, there we go. So that's the soluble, insoluble. See, that's how you figure it out. Okay, it's by those rules. All right, and then here, let's see what we got here. This one is about the same thing. Which one's insoluble? So the one that you see down here, that's going to be your insoluble stuff. So in this case, you're going to have to put, all right, let me write these down because this is going to be interesting how they work. All right, so you've got barium chloride, right? So BaCl2 that is going to join water, it looks like. No, iron what? Iron hydroxide. I don't know. It's one of the two. Let's see, what does it say? Barium hydroxide. Oops, nope. Opposite. Let me erase this. Okay, that's hydroxide there. Okay, so it's barium hydroxide and iron 2 chloride. Okay. Okay, that is what you want to know is what's going to happen. So see, this is one of those reactions where I told you that these two are going to switch places. So if you decompose them into their ions, right? That's what it's going to be. So then this guy is going to join this guy, and this guy is going to join that guy, right? And we need to know which one of these is going to be insoluble. Remember, we said that hydroxides are insoluble. So then that guy right there is the iron hydroxide. And that's how we know. And that's why these two are down there. You see that? And these two, barium and chlorine, are up here. See, that's all. So that's how you know. You have to do an actual decomposition of the ions because that's how it's going to happen. They're all going to get into solution. And the reason I say that in order for the solution to happen, one of them has to commit to it. And so since it's committing to it, it has to fall out of solution. and then the other ones are only free to join each other. You see that? So then that reaction will happen because of that. If iron had been soluble also, it would never have happened. Okay? Because they all would just sit in the water going, hey there, I can join with you, or I can join with you, and they would join each other all the time. It never happened. Okay, so this one in particular is going to actually end up being barium chloride, barium chloride plus iron hydroxide. And this one, I put it like that because that's the precipitate. That's the one that falls out of solution. Okay, so that reaction happens. All right, that's that one. Let me clear all that stuff. All right, so the next, let's see, mouse, the next one. This is just identifying chemical reactions again. So basically, did a chemical reaction take place or not? And this thing's taking forever to load. Must be my internet, must be faltering, and my internet's super fast. Yeah, it is low. That's what it is. It's just taking forever. I'm guessing that's what it is. It's just like the other one. Let's see what else we got. Another chemical reaction identification. See, all of these are identifications of chemical reactions. So is that a chemical reaction? Yes. Oh, this is the one that I was telling you. It doesn't look like one, but if you notice the green things switch places. So yes, that is a chemical reaction. See? And this is electrolytes. That's the other one. Okay. So what is an electrolyte? An electrolyte is an ionic compound. So whenever you have an ionic compound in water, it's going to break apart into its ions. And those ions are charged, therefore they carry electricity. Okay, so this one and this one are both electrolytes because hydrogen chloride is going to divide into hydrogen and chlorine and sodium and hydroxide over here. So, but sugar, it's not. Sugar is not going to do that because it's a covalent compound. All right. Right here, there's another one where you might want to say water is an electrolyte, but water is not. Only sodium chloride is in this one. Okay. Because that's a covalent compound, and this is also covalent, but it could separate into hydrogen and hydroxide, which it does. However, it doesn't carry water. I mean, carry electricity. That's why how you know. And that's it. That's basically all of the ones that we were looking at. The main ones that I wanted you to make sure you knew how to do. But we will, like I said, we'll cover more of this same thing next time. So, okay.
Thanks for going over. Appreciate it, Dr. Badea.
Oh, no problem. And that's all. That's all I have.
Sweet deal. So thank you for the Zoom class today. We appreciate it.
Oh,
I guess we'll see you
I
next
appreciated
Tuesday.
it too.
So tomorrow you have a Zoom class for your Wednesdays course, right?
Yes, I do. I told them that I would, and we're not even supposed to be in school, but I told them that I would, so I'm going to.
Okay, that'll work. That'll work. Well, Dr. Badea, you have
Yes.
a wonderful holiday and happy Thanksgiving to you and your family.
Thank you. You too.
Yes, ma'am. See you Tuesday.
Okay. Bye-bye.
Bye.
Yeah.